Diffusion and dissolving. In this video, we are going to compare diffusion and dissolving. So if you haven't seen our video on diffusion, you may want to pause this video, take a look at that, and then continue. Diffusion, as we know it, is the spreading of particles from an area of higher concentration to an area of lower concentration. This means that for diffusion to take place, there must be a concentration gradient. On the other hand, dissolving happens when the particles of a solvent find their way into the interstices of a solid structure and pull the particles apart. So the solid structure crumbles in the solvent. Diffusion and dissolving happen at the same time. However, dissolving always precedes diffusion. There are also occasions where substances may diffuse in a given medium where they are not soluble. Diffusion and dissolving. In diffusion, particles spread out across a concentration gradient, whereas in dissolving, the solid structure collapses in the solvent. During diffusion, the particles of a substance can spread in a medium where that substance is not soluble, and a very good example is dust spreading through air. In dissolving, the solute must be soluble in the solvent. If the solute is not soluble in the solvent, then it is not going to dissolve. The higher the solubility of a substance, the faster is going to dissolve and the faster is going to diffuse in a given medium. Similarities between diffusion and dissolving. Both are temperature dependent. So a change in temperature will affect the rate of diffusion and solubility. An increase in temperature will cause particles to acquire more energy, and the higher the kinetic energy, the faster the particles will move. So they spread out more easily when the temperature is high. However, a change in temperature will affect dissolving differently depending on the solubility of the substance in a given solvent. In some cases, an increase in temperature may increase solubility, and in another case, may decrease solubility. Stirring enhances both diffusion and dissolving. And a very good example is when you make your tea. When you add a spoon of sugar to your tea and you stir your tea, the sugar dissolves quickly and spreads across, making the whole tea sweeter. But if you just put the sugar there and not stir your tea, you notice at the end that you still have some sugar particles settled at the bottom of the cup. The higher the solubility of a substance in a given solvent, the faster that substance will diffuse in that solvent. Now, let us recap. Diffusion involves the particles of a substance spreading out through a concentration gradient. Dissolving is when a solute disappears in a solvent. The resulting mixture may or may not be homogeneous during diffusion. The solution made when a substance dissolves in a solvent is always homogeneous. Dissolving and diffusion are temperature dependent. Stirring enhances both diffusion and dissolving. The more easily a substance dissolves in a given solvent, the faster that substance will diffuse in that solvent. See you in our next lesson.